All right, today we're going to be talking about angles and angle measure. Angles and angle measure. And before that, we're going to say that a ray is a part of a line. It has one endpoint and extends indefinitely in one direction. All right, so right now, if we put a point on our paper, call it point A, and we just go up and to the right and put an arrow on the end of that ray, we would call this ray AB. When you're describing a ray, the letter in the description is always at the beginning of the ray. And oddly, it's the beginning, the starting point of the ray is called the end point. All right. But when you're describing a ray, you start with the end point, and then you pick one other point on the ray. So if we had a point right here, call it point D, and now we go up and to the left, and we put point F on here. How do we describe that ray? Ray, what letter goes first? Good, ray DF. When you're describing a ray, you always start at the end point, okay? So if you look at that diagram on the top of page 36, if we get something like this, where we've got a line and we've got point H and J, point K, all right? And a lowercase cursive is a name for this line here. So this would be called line L. So this line L has a bunch of different rays in it. All right. It's got a ray that starts at J and goes through K. So we've got ray JK. There's another ray that starts at H and goes through K out here to the right. So we've got ray HK. We've got a ray that can start at K and go to the left through J and H. We would call that ray KH. There's another ray here that starts at J and goes through H. All right, that would be called ray JH. All right, so there's a bunch of different rays or in this line. Just when you're describing a ray, the end point is the letter that has to go first in the description. All right, and then we're going to say that opposite rays have the same endpoint but go in opposite directions. So in a diagram like this, say we got line M, and we've got points B, A, and C. We've got a ray that starts at A and goes through C. So we've got ray AC. Starts at A, goes through C. And then we've got another ray that starts at A and goes through B. So we're going to say that ray AC and ray AB are opposite rays. All right, opposite rays have the same endpoint. Opposite rays have the same endpoint. Both of these start at A. We've got A that goes through C, and then we've got ray AB that starts at A and goes through B. All right, then moving along, we've got an angle. An angle is formed by two non-collinear rays. That have a common endpoint. All right, non-collinear means not on the same line. So two rays. If we're going to draw an angle is formed by two non-collinear rays. So we got a point right here. Call it point A. And then if we take a ray up and to the right at a point A, we put point B on it. And then we put our pencil back on point A, and let's go down and to the right. Put point C on there. We just created an angle. Point A right here, that's called the vertex. Point A is the vertex of the angle. Ray AB is one side of the angle. And then ray AC is the other side of the angle. Now, we can name this angle three ways. Since the angle, or since vertex A only applies to one angle. We could name this angle angle A. Now, we could also name it angle BAC. When you're using 3 points to name an angle, the vertex always has to be the middle letter in the description. Vertex has to be the middle letter in the description when you're naming an angle. And then we could also call this angle CAB. Now, this portion of the angle in here, and now I have to wait on my computer, is called the interior of the angle. And there's a drawing down on the bottom of page 36 where the darker blue is the interior of the angle. So this region in here is called the interior of the angle. All right, if you had a point D, D would be in the interior of the angle. Point E is in the interior of the angle. Points A, B, and C are on the angle. And then any points that aren't on the angle or in the interior, if they're in the shaded region out here, and I can't use any of my colors because my computer will stall. So anything in this squiggly line area, like point F, is in the exterior of the angle. And point H, exterior of the angle. So we could say points H and F are in the exterior of angle A. All right, so turn to page 38 and look at the top. Key concept, classifying angles. If we are classifying angles, the first angle we'll classify is called a right angle. A right angle, if we call this point A right here. Now, lowercase m, angle symbol, and vertex A, you would read this as the measure of angle A. And if angle A is a right angle, you'll either be told that it's a right angle or you'll see a little symbol down here at the vertex. That symbol that's half of a box, it forms a box or it forms a square. That symbol means that the angle is 90 degrees. So the measure of angle A is 90 degrees. And this is called a right angle. Right angles measure 90 degrees. Anything less than 90 degrees. Any angle less than 90 degrees. Here's an example of an angle less than 90 degrees. This is called an acute angle. All right, if I call this point B, the measure of angle B, that's less than 90 degrees. All right, and then the third type of angle is an obtuse angle. So it looks something like this. If we call this vertex point C, then we're going to say that this measure of angle C, we're going to say 180 is greater than the measure of angle C, which is greater than 90 degrees. All right, so obtuse angles measure between 90 and 180. And while we're here, let's just call this this line is also called a straight angle. All right, a straight angle, and its measure, this degree measure right here, is 180 degrees. All right, bottom of page 39, you see a highlighted term, angle bisector. Let's get that definition in your notes. And we're going to say that a ray that divides an angle into two congruent angles is called an angle bisector. A ray that divides an angle into two congruent angles is called an angle bisector. So if we draw an angle on your paper, start again here with point A. So we've got angle A again. You can call it angle BAC. You can also call it angle CAB. A ray that divides an angle into two congruent angles. Congruent means the same or equal to. So if we start at point A right here, put your pencil on A, and you're going to go out to the right, but you're trying to go into the middle of this interior. So right about here. And then put point D on that angle bisector. We're going to say ray AD is an angle bisector. If AD is an angle bisector, then this angle up top here, angle BAD, everybody see it? Starts at B, goes to A, and then out to D. And angle DAC. Those are equal to each other. They're congruent to each other. Those are the two congruent angles. So we're going to say that the measure of angle BAD, here's your symbol for congruent to, is congruent to, it's an equal sign with a squiggly line on top of it. Angle BAD is congruent to the measure of angle DAC. And now there's one other way to note these angles are congruent to each other. If we go into angle BAD right here and we put what's called an arc mark, and then we go into angle DAC and we put another arc mark. Two angles that have the same arc mark are congruent. Two angles that have that same arc mark in there. That arc mark is a symbol telling you that the two angles are equal to each other. So if this angle up top is 40 degrees, what's the measure of angle DAC? 40 degrees. Congruent angles have the same measure. All right, so any questions on any of that we covered today? All right, so let's look at one more example here. Top page 40. We've got a diagram that kind of looks like this. We got points M, K, and J. You got another ray coming out of K that goes through N. And one more ray that comes out of K, and it goes through L. Told that KJ and KM, so K to J and K to M are opposite rays. KN, from K through N, it bisects JKL. All right, so you got a ray that comes out of K and it goes through N. It bisects JKL. So that means this angle is congruent to this angle. Then you're told if the measure of angle JKN is 8x minus 13, this angle measure right here is 8x minus 13, and NKL is 6x plus 11. So this angle up here is 6x plus 11. Find the measure of JKN. So find the measure of angle JKN. So that's this angle right here. And if I could use my highlighters, it would make this much easier for you, but every time I touch my highlighters, my computer stalls. So if these two angles are equal to each other, can't we say that we need to solve for x? We need to solve for x and then substitute it into this 8x minus 13 so we can find the measure of angle NKJ. So we're going to say 6x plus 11 is equal to 8x minus 13. So we're going to solve for x. I'm going to subtract 6x from each side. So we get 11 is equal to 2x minus 13. Next, we can add 13 to each side. And 11 plus 13 is 24 is equal to 2x. Going to divide both sides by 2. And 12 is equal to x. But the question was to find the measure of angle JKN. J, we start at J, K, out to N. So again, it's this angle right here. Here's the expression for the angle. So the measure of angle JKN is going to be equal to 8 times 12 minus 13. And my calculators are gone. Anybody got 8 times 12? 96 or 106? 8 times 12 is 96. So we got 96 minus 13. That's equal to 83 degrees. All right, so the measure of angle JKN is equal to 83 degrees. And while we're here, what would the measure of angle NKL be equal to? If the angles are congruent, and what does congruent mean? The same. If one of them is 83 degrees, what's the other one? 83 degrees. And if this angle right here is 83 degrees, and this angle is 83 degrees. All right, this would be a quiz question. What is the measure of angle LKJ? This big angle right here. L down to K, out to J. If one of them's 83 and the other one's 83, what's the measure of 166? Very good. You take the 83s and you take 83 times 2, or you add 83 to 83. So that's 166 degrees. All right, so that's how you use angle bisectors to find angle measures in this section. All right, anybody got any questions? All right, so your practice for today is going to be on page 41. And problems 1 through 8. And you won't have much time to work in ALEKS today, but we're going to go with 6 ALEKS topics this week. 6 ALEKS topics this week. Anybody have any questions?